Hi guys, welcome to Worms Maths Academy. Today we're going to go through Chapter 3 from the Year 11 text, which is the start of Quadratics. I won't go through all of it, but basically all of your factorising and expanding. Okay, so the first thing, you should have done this in more junior years, but I want to expand this and collect like terms. So the first one, we multiply the 2 in, so you get 2x minus 14, and then plus 5 times x plus 10. Then we collect our like terms, 2x and 5x is 7x. And also I collect my negative 14 plus 10, negative 4. So that's 7x negative 4 minus 4. That 2x multiplies both, so I get 2x squared minus 10x. And then I have negative x squared minus x. Group together our like terms, 2x squared minus x squared, negative 10x minus x, minus 11x. Okay, when we expand out a quadratic, we tend to use FOIL, first, outside, inside, last. So we multiply our two first terms together, 4x, outside terms together, x squared, inside terms together, negative 28, last terms together, negative 7x. So that gives me x squared. My x terms I can add together, I get negative 3x minus 28. That's it. Okay, so same, first, I have 2x times x, which is 2x squared. I have 2x times negative 2 root 3. Now when you multiply 2 by 2 root 3, we multiply outside by outside, which is 4. There's no square root sign here, so I just keep it as root 3. Because it's a negative, I say negative 4 root 3 x. Inside, negative 5x. And then outside, negative 5 times negative 2 root 3 is plus 10 root 3. We can't really join anything together because these two terms don't add nicely, so we just leave it like that. Okay. Here we want to expand this out. I've got 2x, that has to multiply everything in the second bracket, so we'll do that first. 2x times 5x squared is 10x cubed. 2x times 2x is 4x squared. 2x times negative 6 is negative 12x. Then we multiply our negative 1 by everything in the second bracket. So negative 5x squared, negative 2x, and plus 6. From here, all we need to do, group together like terms. So 10x cubed, 4x squared minus 5x squared is minus x squared, minus 12x is minus 14x, and then we've got plus 6. Okay, now what I'm going to do is show you on your calculator to do this. On this one, we put in 2x minus 1, and then we put in 5x squared plus 2x minus 6. We highlight all of it and then choose interactive transformation expand and click OK. 10x cubed minus x squared minus 14x plus 6. With this calculator, the CAS CX, we click add calculator. Now it's a bit different. We want to do the expand first. So you go menu, don't click on the, don't move up and down the numbers, just choose 3 for algebra and then 2 for expand, and then put in 2x minus 1, close bracket, open bracket, 5x squared plus 2x minus 6. Hit enter. 10x cubed minus x squared minus 14x plus 6. So that's how you expand. Okay, when we have something like this, we can use the rule to expand. So we've got a plus b all squared, a perfect square. My first term in this case is x, so it becomes x squared. Then it's plus 2 times whatever a is times whatever b is. So in this case here, a is x, so I get 2 times x times 5. What's 2 times 5? It's 10. So 10x, and then plus 5 squared, which is, oops, I should have worked that out, plus 25. If you need to, you can always work it out the long way, but yeah, it's much easier to use this rule. We can just check it on the cas. So if I have x plus 5 squared, if you hit enter, it'll do nothing. If you click simplify, it'll do nothing. But if you click expand, it'll then expand it out. Okay, so this one, it's the first term squared, so 9x squared, because we have to square the number as well. And then it is 2 times my first term times my second term. So I've got 2 times 3x, which is 6x, times negative 2 is negative 12x. And then it is my last term squared, so negative 2 squared, which is plus 4. Now all of these things come from something that I've taught you previously, which is Pascal's triangle. So I'll try and write out Pascal's triangle over here. If I have a 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, you can see here the coefficient there is 1, 2, 1, which is the same as that. If I was to expand a plus b cubed, it would be, the coefficients will be 1, 3, 3, 1, 1, 3, 3, 1. My first term always goes to the highest power, so a cubed, then squared, then to the 1, and then to the none. My second term starts at the lowest power, 0, then it becomes a 1, then it becomes a 2, and it becomes a 3. Put a plus in between all of them. I end up with a cubed, because that's just 1 and that's 1, plus 3a squared b, plus 3ab squared, that's 1, plus b cubed. This is known as binomial expansion. The first term always starts at the maximum power, which you can see here, 2, that's our maximum power 2. Then it goes down 2 to 1, and then it would be a to the 0, which we know is just 1. My second term starts at 0, then it becomes b to the 1, then it goes b to the 2. And you can do this for any perfect square or perfect cube or perfect to the power of 4. So if I said, we'll do it with numbers. If I said I had x plus 2 to the power of 4. So because it's the power of 4, we use this level. So our coefficients are 1, 4, 6, 4, 1. My x is to the 4, then it's to the 3, then it's to the 2, then it's to the 1, then it's to the 0. My 2 is to the 0, then it's 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and then we put a plus in between all of them. And then we work it out. So here I've got x4. Here I've got 4 times 2, which is 8x cubed, Then I've got 6 times 2 squared, 6 times 4, 24x squared. Then I've got 4 times 2 cubed, 4 times 8, 32x. And then I've got 2 to the power of 4, which is 16. Now if we chose to expand that, I'll do it on this calculator, menu 3, 3, and then I put in x plus 2 to the power of 4, x cubed plus 8x, sorry, x to the 4 plus 8x cubed plus 24x squared plus 32x plus 16. So, I forgot to tell you, it's because I've explained this to most kids in the class. Pascal's triangle, you can see it starts to create a triangle. Where does the numbers in each level come from? Okay, this one here, you start with a 1, but to get your numbers, you always add the two preceding numbers that are above. So here 1, that's nothing, there's nothing there. And then there I've got a 1. Here I've got a 1 and a 2, which makes 3. I've got a 2 and a 1, which makes 3. I've got a 1 and nothing, which makes 1. Here I've got a 1. 1 and 3 makes 4. 3 and 3 makes 6. 4 and 1. 3 and 4. 3 and 1 makes 4. 1 and nothing makes 1. So it's going to be 1, 5, 10, 10, 5, 1. That would be our next level. And that would be like x plus a to the power of 5. We'd use those coefficients. It's not really part of the Year 11 course, but I think it's useful to learn anyway. Okay, now we want to start factorizing. Now, everyone seems to struggle with this. Once you've gone to do quadratic factorizing, they then struggle to factorize the basic stuff. So we look and say, okay, what's the biggest thing that I can take out of 6x and 36x? It is 6x. I've taken out 6 and I've taken out one of the x's, so I'm left with an x. Should change it into an x, looks like a times. And then minus, I've taken 6 out, so that'll be a 6, and I've taken the x out, x minus 6. Here I can't take out a common number. They've both got a and they've both got x. This one I've got a 5. I took the a out and I took out one of the x's, so I'm left with an x. I took out one of the a's and I took out the x, so I've got minus a. This one here, the highest number that goes into 8 and 24. Whoa. The highest number that goes into 8 and 24 is 8. X squared, y squared. 8. I've taken out 2 of them. I've got 1 left. I've taken out all of them, so I'm left with an x. Plus, I took 8 out of that, so it's a 3. I took out the whole x squared and I took out 2 of the y's, so I'm left with 3y. Oh, I missed a few up here. I was like, well, what's going on? Okay, difference of 2 squares is when I have a value plus another value, so a plus b, and then a minus b. If we're to expand that, a plus b, a minus b, we get a times a using FOIL, a squared. We get minus ab plus ab, and then we get minus b squared. And you can see those terms cancel out, so it just gives us a squared minus b squared. So we can use this information when we expand or when we factorize. So in this case here, I've got a minus b, a plus b. That'll become a squared minus b squared, so I'll have 3x squared minus 4 squared. Oops, that squared should be on the outside. So I get 9x squared minus 16. That's it expanded. This one here is a sum. It's a perfect cube, a square, sorry. So we just first term squared, x squared, plus 2 times my first term times my second term. So 2 times x times 3 root 5, 6 root 5x, and then plus my second term squared, which is just this squared, 3 root 5 squared. If I square 3, I get 9, and if I square root 5, I get root 5. If I square root 5, I get 5. When we multiply them together, we get 45. This one here I kind of stuffed up when I wrote it out. That is supposed to be a minus. Sort of looks like it now. Okay, if you can see here, that's a plus b, a minus b. So a plus b, a minus b. This is a difference of 2 squares. If we change this, don't worry about the wrong thing. So here I've got a minus 2b squared minus c squared, because that's a plus b, a minus b. Altogether that's going to be a squared minus b squared. So this term here is your a, and this term here is your b. So a squared minus c squared. You don't have to put a bracket around that one. Some kids will find that hard to see. Okay, so we did those factorising. Factorising by grouping terms, that means you've got to cut it down the center. Okay, what can I take out as a common factor here? I can take out an x squared, and I'm left with an x plus 4. What can I take out of this one? I can take out a negative 3, and I'm left with an x plus 4. Now sometimes kids struggle to see. If I had x squared a minus 3a, you would know, oh, we can take out an a, and we're left with an x squared minus 3. Well, this is the same, but we can take out an x plus 4. So if we take out an x plus 4, we're left with x plus 4, and then what's left over, it's exactly the same as what we had left over here, x squared minus 3. We can take that one step further, x plus 4. This can be written as x squared minus root 3 squared. So it'll be x plus root 3, x minus root 3. Difference of 2 squares. Okay. So this is more factorising with dots. Before we were expanding, now we're going to factorise. Okay, so from here, always take out a common factor first. 5 x squared minus 5's into 125 goes 25 times. Instead of writing 25, I'm going to write 5 squared. So I've now got a difference of 2 squares. So 5x plus 5, x minus 5. On this next one, we can take out a 9 first. We've got x squared minus, it's going to be 4. We're going to write it as 2 squared. So we've got a difference of 2 squares. 9x plus 2, x minus 2. Here we don't have a difference of 2 squares, but we can make it a difference of 2 squares. So x squared minus the square root of 11 squared. So we get x plus root 11, x minus root 11. This one here is a difference of 2 squares. If we rewrite it as x minus y squared minus 6 squared. So that's my first term, that's my second term. So I say first term plus second term, first term minus second term. So that's it factorized. Okay, here when I want to factorize these, I want to work out two numbers that multiply to give the last term. So what are two numbers that multiply to give 12? We could have negative 12 times 1. We could have negative 6 times 2, or negative 2 times 6, same thing. Negative 4 times 3. And I want those same numbers to add to give negative 4. So when you add these two numbers, you get negative 4. So this thing factorized is x, and my two numbers are negative 6 and positive 2. Because we know that when they multiply, they give negative 12, but when we add them, we get negative 2. And we can prove it by expanding it out again. X times x squared. FOIL, so first outside, plus 2x, minus 6x, minus 12, x squared, minus 4x, minus 12. We're back to the original. So we know we did it right. Okay, over here, we want to work out what two numbers, when I multiply them, give me 12, but when I add them, give me negative 7. Now, if they're going to multiply to give me negative 12, they both are positive 12, they're both going to have to be negative. So I could have negative 12 times negative 1, that doesn't give me 7. Negative 6 times negative 2, that doesn't give me 7 when I add them. Negative 4 times negative 3, bingo, negative 4 plus negative 3 is negative 7. Negative 4 times negative 3 is plus 12. So it's x minus 4, x minus 3, which if we expand it back out to check, you don't have to do this by the way, I just like to do it to show you. X times x first, outside, inside, and then last, which is x squared minus 7x plus 12. So we know we've done it correctly. Okay, this is where it gets a little bit tricky. There's a number of different ways you can do this. I'll show you what I think is the most basic way. Because we don't have just an x squared at the front, we've got 6x squared. What we do is we multiply this by this, these two numbers together. So 6 times negative 15 is equal to 6 times, didn't know that very well, negative 15 is equal to negative 90. Now we want to find two things that multiply to give negative 90 and they add to give negative 13. So before all we worried about was the end term, but now because we've got a value at the front of the x squared, we have to multiply the two outside terms together. Okay, negative 90, that's the same as negative 9 times 10. Now that's not going to give me 13. I could divide this one by 3 and multiply this one by 3. So I get negative 3 times 30. That looks no good as well, because 30 and 3 doesn't give me... Go away. What about if we halve this, make it 15, and double this, negative 6, well that's what we started with. That's going to give me negative 9. We could divide this one by 5, so we get 3, and times this one by 5. So we end up with the same thing again. What else could we do? We could divide this one by 3, negative 2, times this one by 3, 45. Still no good. What about if we divide this one by 5, we get 9. And if we times this one by 5, we get negative 10. Still no good. What about if we times this one, divide this one by 2, so negative 5, and times this one by 2, we get 18. 5 and 18, we can get negative 13. If I make this 5 times negative 18, that gives me negative 90, and when I add them together, I get negative 13. Okay, so we know that that's our numbers, 5 and 18. So what we do is we say 6x squared, doesn't matter which one you use, we'll say minus 18x plus 5x. So all I've done is put an x next to them and then put them in here, and then minus 15. Okay, so we know 6x squared is there, minus 18x plus 5x, that's minus 13x, together they make minus 13x, and then I've got minus 15. Then from here we can factorize like we did before. What goes into both of these? 6x, I'm left with x minus 3. What goes into both of these? 5. I'm left with x minus 3. What's common to both of them? X minus 3. And what's left over? 6x plus 5. Now personally I don't like to do it that way. You can do it so many different ways, but what I like to do is go, okay, what are factors of 8x? Well, 4x and 2x, or 8x and x. What are factors of 15? Well, we could have 15 and 1, or we could have 5 and 3. So let's start with 5 and 3 in the top one. If I had a 5 there, I would get 20, and if I had a 3 there, I would get 6. There's no way with 20 and 6 that I can get 2. What about if I had a 5 here, and I had a 3 here? That would give me 12x, and that would give me 10x. With 12x and 10x, could I get 2x? Well, if it was positive 12, there, minus 10, that would give me it. And we know, so from here we can show 4x times 2x is 8x squared, plus 12x, minus 10x, and then minus 15, which is 8x squared plus 2x minus 15. So we know that must be factorized. So I just play around. What two terms can give me 8x squared? It can be 8x and x, or it could be 4x and 2x. There's nothing else that goes into 8. Then I've got to work out what gives me my last terms, and I can try them out here and here and change the negatives and positives around and see if I can get a combination that works. If you know your times tables well, it works really well. Okay, go to the next page. Feels like I think just froze. Okay, come on, come back. So why not let me resize it? Do that there. Ah. Okay. That looks better? No, I wanted that. God, these things are annoying when they don't work properly. Okay, so let's move that back to there. Okay, we can run through. Okay, it won't be much longer, we're nearly done. Okay, other methods of factorizing. Well, here, the first thing we're to do is take out a common factor. So we end up with, once it zooms in a bit, 2 x squared plus 3x minus 10, 2 x, things that give me 10, 5 and 2, but if I want it to be positive, it's going to be plus 5 minus 2. 5 times 2 is negative 10, 5 minus 2 is 3, so we know that's right. With this one here, we can use another variable. Let a equal x plus 1. So then we get a squared minus 2a minus 3. From here, we can factorize that. A minus 3 and a plus, that's not an a plus 1, because we know negative 3 times 1 is negative 3, negative 3 plus 1 is negative 2, and then we can sub a equals x plus 1 back in, so we get x plus 1 minus 3, x plus 1 plus 1, x plus 1 minus 3 is x minus 2, x plus 1 plus 1 is x plus 2. So that's it factorized. Okay, when we solve quadratic equations, we're trying to look for x values that when we substitute them into the function will equal 0. So to solve it, on this cas, you just go x squared plus 11x, and then plus 24 equals 0. Highlight, interactive, advanced, solve. It says variable x, you click OK, so x is negative 8 and negative 3. On this one, menu 3, 1 is solve, and then we go x squared plus 11x plus 24 equals 0, and then we're going to do comma x because we're solving for x. Hit enter. X equals negative 8 or negative 3. Now how do we do it by hand? Well, first we factorize it. So what are two things? I can't really put an equal sign there. Two things that multiply to give 24 and add to give 11. So x, 8 times 3 is 24. If they're both positive, plus 8 plus 3 is plus 11. If we solve this, either this bracket must equal 0 or this bracket must equal 0 for this whole equation to be true. If this bit's 0, 0 times anything is 0, whereas if this bit's 0, 0 times anything is 0. So what we can do is we can say x, if I let that equal 0, I'll get x equals, what's going on now? Stupid browser. X is equal to negative 8, and here if I say x plus 3 equals 0, x is equal to negative 3, which is the answers our calculator gave us. If I was to put negative 8 back into this equation, I'd get negative 8 plus 8, that's 0. 0 times anything is 0. If I was to put negative 3 back into the equation, I get negative 3 here, plus 8 is 5. But if I put negative 3 here, negative 3 plus 3 is 0, so the whole side has to equal 0. That's called the null factor law. Okay, so here we can't take out anything as a common factor. We try and factorize. Things that can go into 2x are 2x and x. Things that can go into 12, we could try 6 and 2. That's going to give me 12 and 2. That's not going to give me 5. We could try them the other way around. 6 and 2. That's going to give me 4, and that's going to give me 6. That's not going to give me 5. Other things that multiply to give me 12. 4 and 3. That's going to give me 6. That's going to give me 4. No good. 4 and 3. That's going to give me 8. That's going to give me 3. 8 and 3 somehow can make 5. If I've got plus 8 minus 3, that will give me 5 equals 0. So I get 2x minus 3 equals 0. 2x is equal to 3. X is equal to 3 on 2. And I get x plus 4 equals 0. X equals negative 4. Now let's just check it on the cas. 2x squared plus 5x minus 12 equals 0. Highlight. Interactive advanced solve for x. Negative 4 and 3 on 2. So we got it correct. Okay, I think, yep, this is the last question we're going to do. So here, I've got problems involving solutions of quadratic equations arise in many occasions, or many situations. The perimeter of a rectangle, is 20 centimeters. So let's draw a rectangle. Perimeter is 20, area is 24. Calculate the length and the width. That's all it's telling us. So because it's a rectangle, we'll call two sides length, two sides width. Now its perimeter equals 24. So the perimeter is 2L plus 2W, and that equals 24. No, 20. The perimeter equals 20. So the lengths around the outside add up to 20. Whereas the area, L times W, is equal to 24, because it's length times width. So now that we know that, we want to calculate the length and the width. So we've got to use these two equations. This equation, I'm going to reorder it. I'm going to get W in terms of L. So first I'm going to say 2W is equal to 20 minus 2L, when I bring that 2L to the other side. And then I'm going to divide 2 to the other side, so I get W is equal to 10 minus L. And then I'm going to use that W. Didn't change. I'm going to use that W and put it into there, so that then I only have L's. So I have L, 10 minus L, equals 24. Now I've only got one variable, so we can expand it out. So we get 10L minus L squared is equal to 24. If we bring our L squared to the other side and our 10L to the other side, we get L squared minus 10L, because when I bring that over it becomes negative, and then I'll have a plus 24 equals 0. From here we can factorize this. L, things that multiply to give 24, 6 and 4, when we add them we get 10, but we want to get negative 10, so they're both going to be negative, because when I multiply two negatives they become positive. When I add two negatives they stay negative. So from here we get L is equal to 6 or 4. When L equals 6, W equals 10 minus 6, which is 4. When L equals 4, W equals 10 minus 4, which is 6. So usually L is the longer one, so we'll say L equals 6 centimeters, W equals 4 centimeters. So that's our solution to that question, and we can test. Come back. 6, 6, 4, 4. 6 plus 4 is 10, plus 6 plus 4 is 20. 6 times 4 is 24. So our perimeter is 20, and our area is 24. Hopefully that helped. You know how to solve... Oh, did I tell you how to factorize? Okay, on your CAS to factorize, we'll do this equation here, and it works for any of them. On this CAS we just put in 2x squared plus 6x minus 20, highlight, interactive, transformation, factor. It's factorized it for us. On this CAS we go menu, 3, 2 for factor. Then we put in the equation 2x squared plus 6x minus 20. I think we have to do x, but I don't know. Nope, we don't. 3, x minus 2, x plus 5. So that's how you factorize any equation on the CAS CX and the ClassPad. Okay, so that's factorizing, expanding, and solving using the Casio ClassPad and the TI Inspire CX. Hopefully this has helped. Good luck. I'll be back soon to teach you how to do graphing of parabolas.